So what does it really look like? Well, if you've taken digital logic, then this should look familiar to you, right? It's called a D flip-flop, right? What's a D flip-flop? It's an element for remembering a bit. You give it on the input called D. It could be a 0, could be a 1. And then on the output, it's called Q. It's what you remembered last time. Well, what's the last time? Well, it's the last time you asserted what's called write enable. If you assert write enable and then remove write enable, it remembers that bit. Okay? And so your D input can change all it wants, but the Q part will stay the old value the last time you asserted the write enable to. Right? Everybody remembers this from basic combinational? No, this is sequential logic. The very fundamental element of sequential logic. And that actually is essentially what's used for, inside your processor, your registers. Just a bunch of D flip-flops grouped together, right? They share a common write enable. Now, the output Q or Q bar, that's just polarity difference. Q bar means the complement of Q. And remember, a lot of times these are just cross-coupled inverters, so you get both the Q and its Q bar for free, right? Because they are cross-coupled. So you have both a true version and the complementary version for free, and it just is a matter of which one you want to make available. So a port looks like this. Basically, that D flip-flop acts as a control signal to that switch, right? Remember that button, when you press it, when you release it, right? It's like that. That's what a transistor is. A transistor is like a little switch, except you don't use a finger to press it. You use a voltage to press it, okay? And in this case, you read or write or you set some value in this what's called a port latch, what Intel calls a port latch. Essentially, you think of it as a D flip-flop, right? And the Q output, or I should say Q bar output of this D flip-flop acts as your finger or the control signal on this switch, okay? And this switch on one side is connected to the ground. The other side is a pull-up, okay? So when you press it, which is like when Q is Q is when you set Q equal to 1, Q bar is 0. So that means it's disconnected, that you're not pressing it. When Q is 0, what happens? Then that's like Q bar is 1, and 1 means pressing it, and that establishes the path to ground, and that pulls it down. Okay? We'll see a few slides to do this. So anyway, so by setting the D value to 1, it leaves the switch disconnected, and that means it's pull up, right? Because it's controlled by the complementary or inverted signal of Q. By setting D to 0, that's like pressing the button, right? Because Q bar is now 1, and that establishes a connection to ground, and that pulls it down. Okay. Now, keeping that concept in mind, so we can see some example. So now, so that D flip-flop is what Intel calls a port latch, and latch is basically, another term for D flip-flop. But I'll explain the differences in a little bit. Now, so to write to the port latch, this is what happens. You can use the move instruction, move P1, and then you can do the immediate value like 05E hex. So that means the 5 is 0101, E is 1110. So they get mapped directly to P1.7 all the way down to P1.0, like that. Okay. Now on bit order, it's big endian. Okay, so the 01011110, that goes from the highest order bit to lowest order bit. You can also do individual bit access. Remember that the move or set B, these take the bit address, right? So P1.1, that's a bit address in the SFR space, right? P1 is hex 90, so P1.1 is hex 91. That's the bit address for P1.1. You can clear, that's like setting it to 0. Okay, so port latch. This is a concept that Intel uses, or this is a term that Intel uses to refer to the D flip-flops that are associated with the port. But I would say this is a rather exceptional use of the term, because I think in Intel terminology, when they say latch, they refer to the hardware concept. When they say a register, they refer to the software concept. Okay, even though they might end up being the same thing. But if you look at everybody else in the world, not Intel, then that's not how they use the term. Even TI, even though TI implements the 8051, they still use the different terminology. So what's that? Well, so strictly speaking, in digital logic anyway, latch refers to a D flip-flop that grabs a new value every clock. Whereas a register refers to a D flip-flop with a write enable. Does that make sense? So, and if you have done any kind of like the, I suppose two-phase clock design, digital circuits, then you know, right? There's phi 1, phi 2, and these latches allow you to build pipeline circuits, and they would grab a new snapshot of value every cycle, right? But a register does not, unless you explicitly set the write enable. Then on the next clock edge, it will remember the value. Okay? So a latch is one without an enable. A register is one with an enable. That's the standard terminology. Okay? But Intel did not follow that. Intel thought, we're just going to call these whatever we like. So they think latch means hardware and register means software. But if you read documentation in TI datasheet, they don't call it port latch. They call it port register. Okay, just so that you know. This can be confusing, but yeah, I think it's important to get the terminology straight. Of course, no, there are a few other companies that kind of follow Intel's non-standard usage. So, but you should know the standard usage is what I show here. So a port latch is, I mean, by everybody else should be called a port register, and TI does call it a port register. Okay.